We're studying AS level computer science, and we're starting abstract data types. Now, this is the first class on it. In the last class, we looked at file handling. Yeah, that's what we did: how to open a file, how to close it, how to enter data into file. We'll do a lot more about it when we do questions. Let's first finish this chapter, then we'll start doing questions on this chapter. Now, abstract data types first. What does abstract even mean? What is the meaning of this? Let's look at that. Abstract data types. If you look at the word abstract, what it really means is that it is this right here is, let's say, unconventional, or perhaps let's say specific, unconventional, and it's used specific, unconventional. It has, let's say, it's specific to a certain use. Now, there's no general purpose. Also, let's say, how does it differ from list? List or arrays. Arrays. How does it differ from arrays? Arrays are not abstract. They are something which are pre-built into your computer. On the other hand, not always pre-built. Pre-built into programming language. That's what I want you to remember from this. Forget the specific unconventional. This is what it means. So it's something which you have to make yourself. Data types are basically, it's used to store data or used to store a collection of data. On the other hand, arrays are pre-built. They are pre-built into programming language. And another thing is used to store a collection of data of same type. That is the difference. Now, they will not ask you in the exam to make difference between these two. Not in this way, especially. Now, let's move on to the real stuff. That what kind of abstract data types do we have? There are three kinds of these. Please write this down in these things in your notebook. You don't need to write this or this, but write this down, the types of abstract data types. Types of ADT. The first one is Q. Next one is linked list. Let me type it out. And finally, we have stacks. Tell me when you're done writing.
To start upwards. Only the types of instance.
Yes. This and the title here, this part. We'll look at these things again, the properties and how they are. We'll look at that afterwards. Done. Let's start with stack. Yep, let's start with stack. Now, what is the stack? Stack is basically it's a data type. Yeah, it's a data structure, and it's used to. It has this principle, LIFO principle. Okay, what does this mean? This means last in, first out. Okay, what does that mean exactly? I'll show you an example. Let's say you have a basket, or perhaps something like this. Okay, let's say a well of something, a huge container. Now what you do is, let's say you put some marbles inside it, perhaps which look like this. Okay. Now inside this, there's the first one I put, right? There's the second one I'm putting inside. There's the third one. Now you tell me, this is the first, this is the second, the third. Which one, if I wanted to remove marbles, which one will I have to remove first?
The third one.
The third one, even though this was the last one. So the last, whichever is the last guy inside, that's the first one I'm removing. To get to the first one, I'll have to go from the bottom, or from the last, then to the second, then to the third, then to the first. Okay, is that clear? That's how it works. Now let's just look at it. Before we go to the book, let's see what it means. Removing, let's say, accessing an item, or accessing / removing an item is called pop, while entering / pushing an item is called push, actually, yeah. So entering or adding, basically, is called push. These are the two things you need to know. And we'll learn in our class by using programming, how do we do these things by using a stack. That's all you need to know. Then write this down first and tell me when you're done.
The diagram too.
Diagram, not yeah, diagram too. Just make a rough sketch, so you can come back and revise later. The diagrams are a very big part of maths, specifically. Not so much in computer science, but in maths, diagrams are very important. We look at that in the maths class. Done?
Done.
All right. Good job. Now let's go back to the book and we'll start reading from there. Read. Read from stack outcome. Can you see the book? Yeah, you can. So from here to here. I can't hear you.
Is containing several items operating on the last in. First out, LIFO principle. Items can be added to the stack and removed from the stack. The first item added to a stack is the last item to be removed from the stack. What
last item. What does that mean? Let's read this line one more time. The last line, this.
Like the second part.
Yeah, so just read it one more time. Out loud.
Is containing several items operating.
Not that one, just the highlighted part. The first item added. Yeah.
The first item added to a stack is the last item to be removed from the stack.
Okay, so let's look at the book, the whiteboard. If you see here, the first item is removed last. That's what they're saying. Yeah. The last item is removed first. The first item is removed last. Make sense?
Yes.
Done. Now we're going to move on to Q. What a Q is, this is what a Q looks like. It just doesn't have the ending over here. Okay, and you still have these marbles. Let's say these are data blocks, which will go like this. Like this. Now this is the first one, this is the second one, this is the third one. But this guy, the Q, actually works on something called the FIFO principle. Now these are not scientific terms. This is something just to make things easy for you to understand. That first in is first out. First in is first out. Clear? Any questions here?
It's like you're in real life.
Like in real life, yeah. Now, I'll just write it here. Adding is called NQ, and removing is called DQ. Now we'll also have to see how this is done. It's not important to memorize, but we need to see how all of this is done. We look at it afterwards in like, let's say 5 minutes. Now start writing. Tell me when you're done.
Good.
Done. Okay. Now I'll tell you what it. I'll show you some diagrams here. A linked list looks like this. Or to be, that's the, I will get to that actually. What this is basically, it's a connection of, let's say, several items using pointers. Let's say, or collection of several items. Collection of pointers, okay, forming a chain using pointers. Okay, what is the meaning of this? What this means is, perhaps, how does a chain look like? How does that look like? This is how it looks like. Perhaps you have one item here. Now there's one cell. What we'll do is we will bring one more, or perhaps we'll make this. Just a second. This, we have this guy. Then I'll have one more of just this guy. Okay, another one, then another one, then another one. Now what we do is we link these guys like this, perhaps like this. Is that clear? Now these things in the middle are called pointers. These things, these black lines. Okay. Now there's one more thing here, which is something like this. Okay, I'll tell you what all of this is. First thing first is that this right here is a node. Okay, it's one data item. Okay. And what happens is that linked lists have nodes and pointers. Okay. Now this has two things, node and pointer. It's an item like this. This is your node and your pointer. Now you realize that all of these items each have a node and a pointer. In the node, we can store some data, right? And the pointer tells us direction to the next item, or direction of tells us. I'll write it here. What is the pointer? Pointer tells direction of next node. And in the start, we have something called the null pointer, which is going to look just like this. Let's say which is also the start. This is the first item, second item, third item, fourth item. Now, what are we seeing here? What we're seeing is that first we have a starting one, we have a pointer. That pointer is showing us the direction to where the first item is. And then the first item shows the direction of second item. Second item shows the direction of third item. Third item shows us the direction of the fourth item. And then this will keep on going. Let's say this will tell us the direction of the fifth item. And then the fifth one will tell us the direction for sixth item. Okay. Now you tell me if you have any questions here. Ask me doubts.
What's the purpose of it though?
What is the purpose of this?
What's the purpose of it?
What is the purpose of it? I'll tell you. Purpose is to store memory.
Data.
Or used in memory, especially used in memory. What memory? Let's say, if I tell you, perhaps it's especially used in memory. Now, not just storing data, but memory storage. That's what I mean. Okay. If I tell you, I want to, we realize that all of these have a direction. They have a direction, and they can point us somewhere. Okay. How this helps us is it can allow us to store things and then know where the next thing is. For example, I have a movie. Okay. A movie like this. Now this movie right here is, let's say, these binary digits 1 0 1 0 1 0. Is that clear? This is the data, the binary data. Now what I have to do is I want to store these guys, so each of these will be played in sequence. So I can do one thing. I can store 1 in the first item. Okay, the first item here, and then in the second item I can store 2. But what I want is that this guy must lead to the next item. So always the first item will point to the second item, the second will point to third. So what this ensures is that the correct order is always maintained. Make sense? Now I want that in the third one, let's say, what is the third binary data here? What is the third one? This is the first one, second one, third one is 1. So 1 is stored in the third one. Now each of these has a pointer, which will tell us the direction of the second item. Okay, second direction. So when I play 1, I know where to go to find the next item. Then the second item has the direction of the third direction. Does that make sense? It's like a chain of people who know the direction of the next person. So they can lead you forwards. And this guy will have the item of something called the fourth direction. But what if I want to end it? How do I end the length of this? Because I only have 5 items. I don't want it to continue forever, right? So I'll have to end it. And that is where we have something called the end pointer. I'm just showing you a graphical representation right now. Let's go to the book. I want you to start reading from here, Q. Read it, Corinne.
I'm not seeing. I'm not seeing anything.
You're not seeing anything?
From why?
The book. Can you see the book?
No, I see.
Now you see. Okay, start reading. Q.
Yes.
I want you to.
A list
Yeah,
of containing a list containing several items operating on the first in, first out FIFO principle. Items can be added to the queue and removed from the queue. The first item added to the queue is first item to be removed from the queue.
linked list.
Sorry, like this?
Yeah, linked list.
A
Read
list
it.
containing several items in which each item is in the list is point to the next item in the list. In a linked list, a new item is always added to the start of the list.
Start of the list. Now this is important. Yeah, let's add that here. Did we write? Oh, we didn't write this. Okay, we can do. The principle is, or adding.
Linked
this
lists
also,
was
in
the same principle
as Q.
Q.
No, not Q. Sorry, it's actually a bit different. Now it's actually very different. I will see where, how. So in the exam, you need to know how to remove, add, and edit linked list. These are the three things you need to know. Now, adding always happens in the start. Now that's not always the case, but you need to memorize this because your book is telling you. Yeah, you can also do other things, but we need right now we just know that adding happens at the start. You can remove and you can edit. So this is about adding. This is not about removing. Okay. Yeah. Fine. Next, and look at the diagrams here. Can you see this? Top pointer. We have base. Look at the stack first. What stack means is, in stack we realize that everything is you have to remove from the from here. It's LIFO. So what will be removed first? This guy will be removed first. Yeah. Then this is the second item, the third item. So what happens is you remove the last item first. That is why the top pointer is at the last item. Top pointer is at last item here. But on the other hand, if you look at Q, which is FIFO, the front pointer, which is at the first item, because you remove the first item first. Yeah, this guy. This and this. So this 79 here in stack is removed first, even though it's the last item. But in Q, the first item is removed first. Fine. Let's continue. Yeah. Base is start. End pointer is last. And let's look at a linked list now. Can you see this?
Yes.
Now, Corinne, I want you to look over here first. We have this thing called the start pointer. Something called the start pointer. Okay, we have to make changes here. So start pointer and the end over here. So first, what's happening is you start here, then you go here. There's the first item. There's the second item. This is the third item, and there's the fourth item. Now, why is this one the fourth item? Because look at the chain here. We start here, we go there. Instead of going here, we don't do that. We go from here to here. And then we go from here to here. So it depends on which sequence are the list organized. Is that clear? Fine. Now let's change a few things here. In this right here is called the start pointer. And this is the null pointer. It's null slash end pointer. Is that clear? So let's move on. I want you to start. Please read this as well. This one. Corinne, can you hear me?
Yes.
Yes. Now I'll actually give you the summary of what's written here. What they're saying is we use pointers. Okay, use pointers, and the linked list, the LL, use something. You make use of the sorting algorithm. Okay, so these guys use sorting. We look at that how they do it. We look at that after it. But all of these linked list, queue, and queues and stacks, all of them use pointers. All make use of pointers. Yeah, that's it. But only the linked list use sorting to store items. Now please read from here. Stack uses 2 pointers. Corinne, read from stack. Stack
Yes.
uses 2 pointers. Read it out loud.
Until when?
Until here.
A stack uses 2 pointers. A base pointer points to the first item in the stack, and the top pointer points to the last item in the stack. When they are equal, there is only one. What?
When they're equal, there's only one item in the stack. Why
One
is that?
item in the stack. Oh,
Do you understand why?
no.
Look, it's okay. It's okay. Look, now this guy. Let's say we make a stack of 2 items,
A stack.
3 items. Let's say 1, 2, 3. Now, can you tell me which is the start pointer, or which is the top pointer here? Top pointer is the last item. Yeah, top is last item, and the first one is the base, which is the first item for stack. Let's do it on the whiteboard. Stack. Now, in this case, if you make, let's say, an example of 3, 1, 2, 1, 2, 3. This will be your top pointer, which is last item, and this over here will be your base pointer, which is first. Fine. Now, what if I only have one item in the list, in the stack? 1. Now, what happens is both of them are the same. Top and base. Because there's only one item. So both are same.
Yes.
Same when only one item. Now please write this in your notebook. Example.
Done.
Done? All right, good. Now we look at the next things. A queue also uses 2 pointers, yeah? What are they called? Queue uses 2 pointers. Let's look at the example here. Example. This is a queue. Okay, it has 1, 2, 3, 4. Now queue has front and end. Front pointer and end pointer. Fine, that's what you have. Now front pointer is, you have 2 pointers here as well. But the important thing is actually first front pointer is the first item, first, and the end pointer is the last item. And again, the same thing. If you have one item, let's say 1, then top and front and top are same. Front and end pointer are same. Perhaps, let's say equal. If one item. Done writing?
Almost. Done.
Done. Now for this guy, I don't think you should look at the whiteboard for this. Let's go to the book. Now, if you see here on the book, just write this down. You have 2 pointers again, start pointer, and this guy right here is called the null pointer, which is last item, and start pointer is first item. Same as Q, but the working is different. The start pointer is first item, null pointer is last item. That's all you need to know. One thing you need to realize is the one about only the start and null being same does not work for Q, for linked list. So if one item, let's do it on the whiteboard right here. Example, if you have start here, go forwards,
Start.
and this is called start pointer. Okay, this thing, okay, start pointer, then this thing is called an item. An item has two things. The pointer, sorry, the node, and then the pointer. Pointer of what? Of next. And let's say the next is another item. Fine. And this right here will be called the null pointer. This is the last item. Null pointer. Yep. Try this in your notebook. Example. And if you have one item, then what happens is this is what it looks like. You have your start pointer, then you have your node, the first item, then that's it. So start, and this is your null pointer. Null pointer. This is first item.
I'm done.
Done. Okay, now we look at something called the operations of these guys. How do they work? Just a second. How operations of stack. Now we have three operations. Yes. The first thing is setting up or initializing stack. Okay, or you can call this setting up. I'm restarting the meeting. Rejoin.
Yes.
Now we have three operations of stack. Initializing, setting it up, yeah, adding and removing, pushing or popping. First, how do you set up a stack? Stacks are, you need to realize one thing.
Who said it?
Stacks, yeah. Are you saying something, Kulin? Now, stacks are even queues and linked list. All of them are made using arrays. Okay, all of them are made using arrays. Now, let's start by making a stack. That has three. You have to declare a few things. First, you declare the array. Then you declare the top pointer, base pointer, and the stack full. Now, what are the purposes of each of these? Let's make an identifier table here. Kulin, can you hear me? Kulin, can you hear me?
Yes.
Yes, that's good. Now we have a few things here. The first thing we have is identifier, data type, and the description. We're using a few things here. We're using at least 4 variables. And what are these guys? The first one is the few things you need to know are first you'll have a stack, you'll have a top pointer, you'll have a base pointer, and finally stack full. Now all of these are integer except the stack, which is an array. Green, write this in your notebook. Initializing stack, the code, and the identifier table. Perhaps you don't care about this part. Actually, let's forget this. This part is important. Are you all right?
My son was just
A description about a stack is ADT. That's what it is. Top pointer tells us last item. Tells that, let's say, direction of last item. Location of last item. Base pointer tells us the location of first item. And stack full tells us if stack is whether stack is full. Number of items. Write this down in your notebook. Tell me when you're done.
Hey, Pantorio.
All right, Corinne, can you hear me?
Yes,
Yes. Are you writing?
I am. Even the Eva, even the identifiers and descriptions.
You know the identifier and the description. Yeah. Have you written the code down?
I have
You have?
the description.
You have written this down and this. What about this one? The code.
This part, the code, yes, but the description identifier. I'm finished.
You finish. Yes.
I mean,
Finish. Yeah. Take care. Take your time.
then
Done. Okay. Now I'm just going to show you how to set, let's say, popping, not pushing first into the pushing item, which is adding, right? Adding dash push item. How do we do this? Now for this, we need to use an if condition first. Look, this is this one. I'll tell you what's happening. The first thing that is happening is if top pointer is smaller than stack full. Stack full is the number of max items. Let's just say the number of items or max items. So top pointer, what was the top pointer? The last item. Last item. Now that if the last item is smaller than the max items possible, right? Or the number of items possible, then what we'll do is we'll add another pointer to it. We'll increase the top pointer, and over there we'll add an item. Else, if the top pointer is not smaller than stack full, or if it's not smaller than the maximum number of items possible, then we'll say stack is full, cannot push. Now, should I show you this on the Excel, or should I give you a demonstration? Is this okay? Any doubts here?
on the stack top pointer, what does that part do? Like
Stack,
the stack time to
This
push.
one? Yeah. Okay. This one is the array. Yeah, array index. What it does is it adds, I'll just write it down. You should write it down as well. Adds a new item to top pointer, or let's say to new top pointer, or let's say incremented top pointer, or let's say adds new item to array position, array index of here top pointer. Read this out loud.
Add new item to array index of incremented top pointer.
Yeah. So what happens is if I see, look, we have this right now. Okay. We have an item like this. What do you say? A stack. A stack over here. It has these many items. Goes on and on. Okay. Now right now I only have two numbers here, 2, 3. Or let's say we have 82, 64, 52. Done. Now this is going to be my top pointer. Sorry, not top. Or just a second. Just a second. Like this. Okay. Now the first item is going to be my base pointer. And the last item is going to be my top pointer. Yeah, we know that. Top pointer is last item. Last. Now this one right here, how many numbers can we store here? We can store 4, 5, 6, 7. Now 7 is the stack full. That's how many I can store. Okay. Now what happens if I want to add another number? Let's say 89 to this. How does that work? What it will do is if I want to add, let's say 10, where will I store it, Corinne? Where will I add this number? Which position?
4.
4. Now what is my new top pointer?
4.
4. So, but it doesn't happen like this. It does happen exactly like this, but there's one difference. What happens is when we're adding, first I'll move this guy up. So it's now I increment this. That's what's happening, right? Increment the top pointer by 1. So that goes up. And then I'll bring that new item to this place. And how do I do that? This is called array index, or let's say doesn't add it, cut this part out and write assigns. Same thing, doesn't make a difference. Assigning is a different word. So write this down in your notebook, this part.
Yes. Then
That's else if top pointer is not less than, let's say not smaller than stack full, then that happens. Now what will happen if I, let's say I have new numbers here, 9, 6, or 11 and 12. Now my top pointer is here. How does the code work? Now Corinne, read the code and tell me how does it work. First thing, check if top pointer is smaller than stack full. Is it true or false? Well, this
false.
false. It's false. So what will happen then? This will go here. Else, output stack is full, cannot push. So I can't add the number, let's say 50 to this because it's already full. Yep. If false, let's say false, then this will happen. That's it. Now the last thing we have, we'll finish this today, which is how to pop an item. Okay, just a second.
Can you button just?
Are you saying something?
No.
All right. Okay. So end pointer and if else, just add some space here. Okay. This is how you do removing. Please keep the indentation correct. Okay. After if we have an indent, after if we indent here, then after then we have an indentation. Put a gap. Fine. Now just try to do this. Okay. Write this down. What is happening here? Let's first understand what's happening. Now, if top pointer is, I'll bring the list here. Just a second. Okay. Our top pointer was perhaps over here. Okay. So could you read the code first out loud?
If the pointer is equals to base pointer minus 1, then output stack is empty, cannot pop. Else, the stack top pointer is assigned to item. Top pointer minus 1 is assigned to top pointer. And if.
And if. Now what's happening? Is this confusing? Is it clear what is happening? Should I explain? I'll explain this just a second. Now, first thing is top pointer is base pointer minus 1. What is the meaning of this? Now this is checking. Okay. Now base pointer. Look. Let's look at a list here. Look. Now if you do this, you have only one item here. Perhaps forget this. One item.
Gente, pessoa fez a classe.
And this right here is 50. Now this is our base pointer, yeah, and but this is also our top pointer. Okay, both of them are same. Okay, but the issue is that what happens if the top pointer, if you have no item in the list, right? If you have no item in the list, then the top pointer will be 0. If you look over here first, look, what is the top pointer at the beginning?
0.
0. So that means it's empty. Okay, there's nothing there. Okay, let's look first over here again. If I have one item here, 50. Okay, top pointer, base pointer are same. There's the first item, second item, third item, 4, 5. Right now, what if you have only one item? What is the top pointer? What is the base pointer? Tell me.
Huh?
What is the top pointer?
1.
1. Base pointer?
1.
1. So then we know that they're same. So there's one item. Okay, we know that already. If the top and base pointer are same, that means that the list, the stack only has one item. I know that. But what if it's empty? Then the base pointer will always be the first item, right? The first place. But if it's empty, then top pointer will be over here, which is how much? It's 0 if empty, right? It's nothing. It's like, let's say there's nothing there, so top pointer is 0. If there's no item, then top pointer is 0. If I do put an item, then top pointer will become here. Right now I have no item, so the top pointer is 0. Is that clear?
Mm-hmm.
Now what if I change this a bit? Let's say okay, that's it. So if the base pointer is 1, then what is base pointer minus 1? Base pointer is 1. It's always 1. So what is base pointer minus 1?
0.
0. And if top pointer is 0, if top is 0, then list must be empty.
Amor. Vou ver tipo uma classe, tá bom, vai vir.
It's all right. It's all right. Just write this in your notebook. Write this part in your notebook. This one. Write it in a different line. Let's just say, when is stack empty? And below that, write this. If top pointer is 0, then list must be empty. Not list, sorry, stack. Okay. So write this first question, and the answer is this.
Moi, je dis on peut bien tu m'en fais faire la classe, tu m'en fais des runs. Amen.
Done. Okay. Fine. Right. Okay. So how do I check if the list is empty? I check by now. They could have done directly if the top pointer is 0, but that's not the best way to write it. The best way is to check if base pointer -1 must be 0. Perhaps sometimes what if the base pointer is 5? Then if it's empty, it must be 4. Right? But we don't look at that. That never happens. So if base pointer is 1, then base pointer -1 will be 0. If it's 0, then it must be empty. Stack is empty, cannot pop. Is this much clear? Up till
Yes.
here? Okay, now let's do else. Now if it's not empty, okay, then fine. We have something inside the in the stack. It's not empty, so we can remove it. And how do I remove it? Let's see how this works. Okay. Now, Corinne, I want to remove 9. I want to remove 9. How will I do it? So first, I'll just remove it. Okay, that's pretty easy. Drag it and throw it away. And then what happens? Which is the top pointer now?
4.
4. So first, what was the top pointer?
Yeah.
First, the top pointer was 5. So I'll say, first I'll take the item out. How do I take the item out? I'll place it into some other location. So I'll say item or last item. I'll say last item, last underscore item. This is my identifier, and I'll assign this guy to this. Let's say stack what? Stack 5. Is that clear? So I'm placing stack 5 into the last item. Then second thing is, so this guy is gone. Okay, removed. It's in last item now. And the next thing is top pointer will become 4. It won't happen automatically. We'll have to do that. So this happens. Right? Let's look at that again. So 9 goes away. Top pointer 9 goes away. Top pointer comes down. So we'll say top pointer now is now top pointer -1. Make sense? Does it make sense? Now read the code one more time from the beginning out loud.
If top pointer is equals to base pointer -1, then output stack is empty. Cannot pop. Else item. Else stack pointer is assigned to item. Top pointer -1 is top pointer assigned to top pointer. And if
Does it make sense now?
yes.
Yes. All right. Now Q is not so different. It's just like this, but we'll do it afterwards. It's just this a little bit more to it. And then linked list is also just like this, but a little bit more to that. We'll do that in the next class. I hope you understood the basics of abstract data types. Yeah. And we finished stacks. There's nothing else coming from stacks. This is only what is coming from stack. And a little bit theory questions such as when is the stack empty? When is the top pointer equal to the base pointer? All of that will come. We'll practice questions. Okay. Now, any doubts, Corinne?
Huh? No, no.
No. All right, that's fine. Yeah, ask them.
I don't know. I think I listen.
You understand? If you have a doubt, you can ask me. You can ask me anything. Let's do one thing. Ask me a general question about anything. Computer science, maths, life, whatever. Take your time.
From your point of view, which paper is more difficult, paper 4 or paper 2 for computer science?
Say that again, louder.
Which paper is more difficult, paper 2 or paper 4 for computer science?
Computer science, paper 2 or paper 4? The theory, right? You're talking about, no, paper 4, paper 2. Okay. Yeah. Fine. So paper 2 or paper 4. Paper 4 is more difficult. not paper 2. Paper 2 is easy. 4 has a lot more things in it. Has a lot more sorting in it. We look at sorting, different types of programming. It's a lot more. So paper 2 is all pseudocode. Okay? Corinne, can you hear me?
Yes.
Paper 2 is all about, paper 2, yeah, paper 2 is all about pseudocode. There's not much programming in it, but paper 4 has a lot more programming in it. Is that clear? So let's say in paper 2, if you
Yes.
don't know programming language, you can still get full marks in the paper. Okay? They allow you to use pseudocode for almost everything. But I will teach you before you finish that. But in paper 4, you have to know programming, right? Because you cannot solve questions otherwise, and that's obviously because this is computer science and then programming. It's not that difficult. If you understand the logic, everything is the same. Look over here. If, and let's say in a programming language, if you have if, it's exactly the same, but then is removed. There's no then in Python or Visual Basic. And else is there, yeah. If is there, but there's no end if. There's not a big difference. You just have to memorize how the rules are. What are the rules? The logic is exactly the same. Yeah. Okay.
Okay.
Yep. Just a second. Stay for a minute.